Hello. So, good afternoon, all. Am I audible?
Yes, Vishnu.
Okay. Yeah. Good afternoon, all. Today, we are gathered here as our college has signed an MOU with NITK Surathkal to conduct virtual labs. And today is the first day of the webinar on introductory training on virtual labs. I would like to welcome our management, our beloved principal, Dr. Kemthos P. Resource persons, Vismaya, Senior Research Fellow, Akshaya, Anusha, Latish, Tapsya, Junior Research Fellows. Our dear faculties, good afternoon all. So, I would like to conclude with a quote stating that today is the opportunity to build the tomorrow you want. So I hope everyone makes use of this opportunity to the max. I would like to call upon the resource person to go on with the webinar.
Thank you, sir. Good afternoon, all. Myself is working as Senior Fellow in Center for System Design, NITK, Surathkal. So today, on behalf of Virtual Lab team, I welcome all the faculty members of SNGCE College to the session. So I will be starting with the intro on Virtual Labs. Then Akshaya, Latish, and Tabasya will take you to the domain-specified labs. So I'll present my screen now. I hope my screen is visible. Hope you are. I request every participants to mute their mic. We'll start. So, hope you're all aware of virtual labs. Virtual labs at MOIT and the National Mission on Education through ICT. So, Department of Higher Education, Ministry of Human Resource Development is National Mission on Education through Information and Communication Technology. Leverage the potential of ICT to make the best quality content accessible to all learners in the country for free of cost. So the various initiatives under this program are Swayam, Swayam Prabha, Virtual Labs, E-Yendra, and so on. So Virtual Lab is one among virtual labs. We know that number of engineering colleges as well as the engineering domains are increasing day by day. But what about the colleges that so virtual lab has been started long years back, that is almost 10 years back, and the virtual lab is less time consuming than a traditional lab, and the physical distances and the limit doing an experiment is not a matter in virtual lab. We are increasing day by day, which will not affect the virtual lab. So the basic idea of the virtual lab is to provide remote access to n number of users at any time and place. When I say virtual lab, it's a 3P lab: space, place, and period. Requirement of physical lab, and one can be, or he or she can be use the virtual lab while requirement of no requirement of anywhere, even while traveling, he or she can use the virtual labs. And there is no time restriction and is available anywhere. Pace in the sense will be having speed while doing an experiment, but virtual lab is a 3D lab that is place and period. You can take it anywhere you go, or you can find experiment in virtual lab. To the salient features, it include remote access to labs and anywhere lab. And the virtual labs are free to use or and can be accessible through internet on any PC and is developed in self-learning mode. So based on the scalability to closer to reality, based, measurement based, and remote record. So more labs are in which the experiments are all modeled 100 plus labs and 1000 plus experiment based on modeling or simulation. So looking onto the measurement based virtual labs, the experiments are developed priorly and conducted and the data is stored. Using remote triggered virtual labs, the actual experiments are triggered based on scalability to closer to reality. Comparing the physical labs and the virtual labs, we know that physical labs are the best solution for the user experiences, but in pandemic situation, we have virtual labs. So for a virtual lab, we only need a device with an internet connection, whereas for physical labs, we need equipments which are of high cost, typically in few lakh rupees. And the virtual lab is designed for 24/7 usage. We know that we will be having a specified time like 9 to 5 college timing or 1 or 2 hour lab sessions, which is limited in time and space. So virtual lab the virtual lab provides options for innovative experimentation, whereas physical lab provides limited options for innovations. So coming on, we have 7 engineering domain and 2 basic science domain. Areas of virtual lab. Looking onto the participating institutes, we have 6 IIT, 1 IIIT Hyderabad, Amrita University, NITK Surathkal and COE Pune, where NITK Surathkal is the only NIT among all the participating institute. So you can also participate under virtual lab by being a nodal center. So SNGCE is already a nodal center of NITK Surathkal. So while visiting National Institute of Technology Karnataka, Surathkal, system design, where all the events related to Center for System Design are all. So what is Center for System Design? Yes. Is where different people from different domain work together. And Center for System Design is a transdisciplinary center for R&D, and the key projects are 3D printing and laser cutting, media production, visualization, PSU, headed by Dr. K.V. Gangadharan, who is a professor in Department of. And the lab is coordinated by Dr. Prithviraj Umesh, who is also Department of Water Resources and Ocean Engineering. Research scholars, project students support these projects. So Center for System at NITK Surathkal mainly for AV and ROV technologies, sound and vibrations, smart experiential learning, and so on. So we have centers under the virtual labs at NITK. Mechanical engineering, civil engineering, chemical and electrical engineering. It's related to the Center for System Design and the virtual lab. We have two social Instagram. So you can follow us on our Facebook ID, that is CSD NITK, and on Instagram CSD_NITK. So Lakupada is a short video tutorial to encourage the students to use the virtual activities. So I'll stop sharing my screen. I'll take you to the home page of the virtual lab. The screen is visible. So VLIN is the link to access to the virtual lab site .co.in, which will take you to the home page of the National Mission on Education through ICT. So moving down, you can find virtual lab is a 3P lab. As I already taught, you can independent of pace, place, and period. You can take it anywhere you go, and you can find your own time to. Are the broad areas of virtual lab. We have 7 engineering. So moving down, you can find all the participating institute logo. Institute logo, you can find all the institutes. So these are the labs developed by NITK Surathkal. We have engineering lab, environmental engineering lab 1 and 2, and so on. So if you are not able to find the labs or the experiments that you are looking, other way to find it over here. Yeah, you can come down. You can save button here. Click on that, which will take you menus, that is demonstration of labs, approved labs, and labs under development. So click all the labs which are under approved section. So we have many labs and science, maths, mechanical engineering, physics, and so on. Is the labs under development. Clicking on that, which will give you labs which are under development. It will sort out you by discipline. So we have many labs in the biotechnology and biomedical, computer, zoology, paper engineering, and so on. So development and approved labs in the VLab Dev site here. Today I will take you to the electronics and communication domain labs. You can find many labs under the domain. So these are electronics and communication domain. So we have labs which are ready for use, and these institute would have this lab. So moving down, and the institute would develop these labs. So first I will select. Yeah. So this electronics lab is an alter lab. You can find introduction, experiments, technology use, pupil, and feedback. So introduction is moving on to the list of experiments lab, and the instruction of browser is given here. So JavaScript and H5 are the technology used to develop the lab. Involved in developing these labs, so you can contact directly them for any query and the feedback session. So you can provide your feedback here, which will for you and for others. So on the list of experiments, there is Ohm's law. So clicking on each experiment, procedure, simulation, quiz, assignment, and reference. So as it is an alter lab, you can having a pre-test and a post-test. So theory will be all about diagrams used in the experiment. So as it is an Ohm's law, we have Ohm's law and so on. Next is the procedure to do the simulation. So for doing this Ohm's law simulation, then we have to keep the resistance value constant. You can find the voltage placed. So the voltmeter is placed parallel and the ammeter reading is DC volt. So finally, you can plot the VA. So moving on to the simulation. Slow. We have the instruction to do the simulation here. Controls. So looking onto the instruction, first we have to set a DC volt value. Click onto the add to table button, and ammeter reading values are noted down in the experimental table given here. This value constant. Take another set of DC volt. Click onto the add, sort it down. So take around 4 to 5 values. You can find the experimental table is updated here, keeping the resistance. And then clicking onto the add to table button, the experimental table is up. Then click onto the plot button to get the plot. So we'll print, click on the print button to save it as a PDF for the future reference. I request every participants to mute their mic. So next is the quiz, where you can send some set of MCQ questions. You can click on your answers and you can, so which will give you the right and wrong answers. The assignment part, it's also some set of questions, the references or the resources used to develop the lab and the experiment.
Headphone
I request participants to mute their mic. Venu sir, please mute your mic. Yeah, continue. So this is all about the basic electronics lab. Next, I will select an digital electronics lab developed by IIT Roorkee. It comes under the upcoming lab section. Direction, objective, list of experiments, target audience, course alignment, and the objective. Moving on to the list of experiments, we have electronics session and the target is applicable for. So this lab is applicable for BTech or BE in EC and the related topics. Coming on to the course aligned to develop the lab. So this syllabus of this lab aligns to the following. And the feedback, or you can provide a feedback which will and for each lab we will be having a feedback session. So for each experiment under the A, theory, procedure, simulation, and feedback. The aim is given here. Theory, as I already told, formulas and all. So as it's an logic gate, so we have and the pretest where you have to some set of MC answer and which will give you the right and wrong answers. So you have to and the procedure or step-by-step procedure. So in simulator one, we have to connect the supply first and we have to input the and if both the switches are on, the bulb will start to glow, or else two, we have an AND gate with two input Boolean output for the corresponding on the check button to verify our output. So simulation of the AND gate. So this is the simulation given here to do the simulation. First, we will connect the battery switch on the first switch. So the battery is connected to the switch A, switch 2, and the input B, that is switch 3. So you can find. So all the specifications are given here. We have an AND gate. We have to give the Boolean. Give the Boolean inputs and the corresponding output for our Boolean input. So you can find that these are noted down in the truth table. Inputs and the corresponding output. The control is updated here. So select all the set of input and output and the corresponding output. Truth table will print the whole page, or you can save it as a PDF for the next. MCQ questions, so you have to next is the references or the resources used to develop the lab. finally, the feedback where you can provide a feedback. So, and communication domain here you can find. Next is I'll show you one more lab from electrical. So these are the lab engineering domain. I'll select IT route A. Is a newer lab. Same like introduction, objective, list of experiment, target audience, course aligned with the list of experiments. Yeah. Aim, simulation, post test, reference and feedback. So yeah, simulation part. Just an familiarization of electrical machine laboratory apparatus. Here and so many such equipment here. Just a familiarization. We'll click on the next equipments. Just need to drag and drop the equipments. You can do the same way. So this is all about and the electrical engineering session also you can find here. So I'll stop my side and Akshaya, Tapasya, my specified labs. So thank you. I'll stop sharing my screen.
Thank you, Vismaya. I hope my voice is audible.
Yes, Akshaya.
Okay. Good afternoon, everyone. Myself Akshay, and I'm working as Junior Research Fellow at Center for System Design and NITK Surathkal. I'll be showing few labs from Computer Science and Engineering. I'll be sharing my screen. I hope my screen is visible. It's the home page of plab.co.in, virtual labs. Is my screen is visible?
Yes, ma'am.
Okay, I'll continue then. So we can find labs for computer science and engineering under broad areas of virtual labs by clicking on the link over here. This will lead to a page of list of labs for CS. So here we can see around 70 labs have been listed under labs ready for use section, and also there are 4 more under upcoming labs. So for the demo, I'll be choosing one of the experiments developed by IIIT Hyderabad, that is data structures. For the data algorithms and data structures concept, we can see around 3 labs have been developed. One is listed under labs ready for use, and 2 more are there under upcoming labs. So I'll directly go with one of the labs, data structures lab. So by clicking on that link, it will lead to a new page that is data structures. So this is the interface similar to the labs shown by Vismaya. Here, these are the sections available, that is introduction, objective, list of experiments, target audience, course alignment and feedback. So on the list of experiments, we can see many experiments have been listed for this particular lab. I'll be choosing one of the experiments, that is tax and cues. So this is the interface for the experiment under this lab. Here we can see there are so many sections are provided, that is aim, overview. In the overview, we can see a short video describing all these sections, what are these sections about, and also there is a prerequisites of the experiment and also overview. And under recap of arrays section, we can see a short explanation is given on the arrays concept along with pictorial representation of the arrays concept as well as time and space complexity. And there is recap for linked list concept as well, explanation along with pictorial representation as well as time complexity. And there is pretest section as well. These are the MCQ based questions to test the user's knowledge of about the understanding on the concept. And we can see separate sections are provided for stacks and queues. So here you can see subsections provided. There is aim given and concept. This is a video on what are stacks, what are its operations and applications, along with pictorial representation of push and pop operation of stack. And under the demo part, this is one of the demos. So here instructions are given how to proceed with this demo. Here there is option to click on start button. We can even increase the speed of execution, or we can even reset or pause. So there are instructions given. Accordingly, we can just follow the simulator. And under arrays practice, here also instructions are provided. There is an empty array along with 3 buttons. So we have to enter the values into the array by clicking on push button, as many values we want. And we can just pop the element by clicking on the pop button. We can even clear the array by clicking on clear button. So this is how the arrays practice section works. And there is short explanation on time complexity of stacks concept. And there is similar way we can see linked list practice. So by following the instruction, we can just do the linked list practice section. There is a separate section called exercise, wherein there is a question given. So user must follow the instructions first. And the question says that a set of elements are given in stack A. By the help of stack B, we have to pop the elements in ascending order and have to display under this observations part. So we are given with 4 buttons. Using these 4 buttons and one more stack, that is stack B, we have to arrange all these numbers in ascending order. So by looking into the array, we can see the least number is 202. So I have to pop all other elements from stack A and push that to stack B. So we can just do that by clicking on the button, pop from A and push to B. Now I can just pop the element, top element from stack A. Next least element would be 2117. It is at the top of stack B, so I can just pop from there. Next least element is at the bottom of stack A, so I can just pop the above element into stack B and pop A. Now the least element is at the bottom of stack B, so I have to pop all other elements into stack A. Pop from B. Next is at the top of stack B. Next least element. Why is it not okay? Next least element is at the top of stack A. I have to pop the top element into stack B. Pop from A. Pop from B. I hope I have arranged the numbers in proper ascending order. I can check the answer by clicking on the button submit. It says correct. So we can just attend for other set of random numbers by clicking on new question. And we can even reset the execution any time in the middle of the execution. So this is how the exercise part works. And there is a quiz also. These are the MCQ based questions to test the understanding of the stacks concept. Same way, these subsections are available for queues concept as well. So one can attempt all these sections, go through all these sections. And there is a separate analysis part given on comparison of stacks and queues, as well as application of stacks and queues, along with quiz. And there is a post-test question. And the further readings and references material, these are the web links provided, referred by the development team while developing this particular experiment. There are coding references as well, so users can just go through all these links. And there's a feedback section, like while exploring this particular experiment, if you guys find any issues or you want any updations, you can just share your experience over here so that the team can update the same in their experiment. So this is one of the experiments available under Data Structures Lab. So it lists sorting experiments, graphs, trees, and certain concepts under this particular lab. So there are 2 more labs for data structures. So you can just explore those 2 labs as well. So this is one of the labs under labs ready for use. You can just explore one more lab that is listed under upcoming labs section, that is below here, that is Python programming lab. This is the interface similar to the last one. So there is introduction given, objective, list of experiments, target audience, course alignment, feedback. So under list of experiments, we can see around 9 experiments have been listed for this particular lab. And you can just choose strings concept. So here there is aim provided. In the theory part, we can see a clear explanation is given on all the string methods that we come across in Python program, along with proper examples. There is pretest questions as well. These are MCQ based questions, code based, and there is a procedure given. These are the steps that need to be followed while exploring the simulator. And there are post-test reference and feedback sections as well. So I'll directly move the simulator. This is the interface. So here we are provided options for concatenate, slicing, reverse, and repetition methods of strings in Python program. So I can just choose one of the options. And this is the interface for the concatenate method under analysis of strings experiment. So here there are 3 panels provided. The first panel is for giving the input to the program, and the second panel will display the program code, Python code, and the result section will be displaying the program output. So here for the concatenate method, we can just provide 2 strings to concatenate. I'll be just providing the strings. We have option here to enter option string also. We can just try that. And by giving the input, after that we can just click on the start button. That will display the Python program in step execute panel. After that we can just go on clicking next button. You can see the program output is displayed in the result section. We can even try for other set of inputs just by clicking on reset button. We can attempt for other inputs. There is reverse also. Here just enter the input. Click on start, will display the program, and you can just click on next button until the execution is complete. We can see the program output. We can even reset the interface to check the results for other set of inputs. So this is the interface, and this interface is followed for all the experiments listed under this particular lab. So these are the labs available. These were the labs available in main site. And as Ms. Maya mentioned, in the VLabs dev section, we have a few labs for CS as well. We can just explore those labs by going to this site. There are approved labs section where we can just sort the labs by discipline wise by clicking on the button. Here we can see 5 labs have been listed for CS as well. So same way, just by going through the theory part, procedure, one can explore the simulator. So I would request everyone to go through the labs provided here under virtual labs for computer science. So with this, I am going to stop sharing my screen, and I'll be passing to the next presenter. Thank you. Thank you, everyone.
Thank you, Akshay. Request Tapasya to take over the session.
Thank you, Akshay ma'am, for taking the class. My name is Tapasya. I'm working as a JRF in NITK under System Design. Center of System Design. So I'll be sharing my screen. So today I'm talking about the strength of materials lab based on civil engineering, so which is done by NITK Surathkal. So this is the home page of virtual lab. So I'll be taking up on strength of material labs. There are different types of labs for the fluid mechanics labs, and there you can just go through. So today I'm taking up on the topic of strength of materials. So I'll be clicking up on the NITK Surathkal. So I'll be coming to a page of civil engineering with the title named Strength of Materials Lab, where introduction, objectives and list of experiments, target audience, course alignment, feedback, everything is visible here. So the main aim of this lab is to provide the knowledge and and that deals with the relation between the internal forces, deformation, and external loads, etc. And the objectives regarding the strength of materials lab is this provides a basic knowledge of the strength of the materials, and here the students can perform different tests on different materials. Okay, so there are a list of experiments if you can explore here. So there are the list here: Izod impact test, Chapi impact test, direct shear test on mild steel rod, direct shear test on timber specimen, direct shear test on mild steel plate, Brinell hardness test, bending test on mild steel, Rockwell hardness test, Vickers hardness test, tensile test on mild steel, tensile test on cast iron, compression test on mild steel, compression test on cast iron, and torsion test on mild steels. Okay, so the next here is target audience. We are focusing upon UG and PG, where UG people includes B, BTech in civil engineering or mechanical engineering, whereas PG, MTech and MS in structural engineering or earthquake engineering or material engineering. So course alignment is regarding the universities which has enrolled here. For the strength of materials, National Institute of Technology Karnataka Surathkal is only involved, and also Vishwesvaraya Technological Universities. So there are some of the universities which has been involved here. So here, if I'm going with the experiment of today, there are almost 14 experiments in strength of materials lab. So I'm going with the 12th one, that is compression test on mild steel. Okay, so the compression test on mild steel here. So first one procedure is for every lab is like aim, theory, procedure, self-evaluation, simulation, assignment, quiz, and videos and references. So these are the procedures we have followed here. So first one is aim of the particular experiment. So here the compression test on mild steel is experiment. So the aim of this experiment is to study the mechanical properties of the mild steel specimen under compression. So the next goes the theory part. So in the theory part, it is regarding how this experiment has been conducted and what are the values and the graphs you get in conducting this particular experiment. So you can go through this particular theory part. So here in this compression test, the material experiences opposing forces that push inward upon the specimen from the opposite direction. So generally, how the compression test works on when when a material is kept in between the two elements, it will be when the loads are applied, it will be getting undergoing compression. So here the Hooke's law states that Young's modulus is equal to stress by strain format. So you can go through this theory part entirely to know more about this particular experiment, how it is getting conducted. Okay, so here are some of the modes, how it is getting the buckling format, shearing formats, everything. Then the failure patterns are also visible here. Okay, so what are the Indian Standard Code books we are available here? So IS 13780 is the compression test has been conducted. Okay, so the next is the procedure, how to conduct this particular experiment here. So here they have provided the detailed explanation how to conduct the particular experiment step by step. Okay, so here objective to study the mechanical properties of the mild steel specimen under compression. So step one is to the machines used here is UTM, dial indicators and scale and vernier calipers. So you can go through the procedures, how to follow the procedure to be used in virtual lab. So these are the procedures to be followed, which I'm scrolling up down. Okay, so these are the procedures to be followed, how exactly it has been conducted in virtual format. So next one you have here is self-evaluation. Self-evaluation is regarding the experiment, what you have gained knowledge by just reading the theory part or anything. So here you can just answer these quiz questions where here the ductile nature of the material in compression test is indicated by any of the four options are here. You can answer it anyone. So if I give none of the above and if I answer all these questions, and you have to click on Once after you answer these questions, you have to click on the option called submit quiz. So here, if you click on submit quiz, the answers which has been answered wrong are highlighted in red color, which means the answers are wrong. You can recorrect it and check out the score here in the below format. Okay, so these are the formation you go for self-evaluation format. Next option you have here is simulation. Okay. Okay, so here is the entire procedure how this particular experiment works. Okay, so first the compression test on mild steel. Here the objective is been highlighted and also the apparatus used here. So apparatus used are universal testing machine, dial indicators, scale and vernier calipers. So once after you see this, you have an option called next here. So just click on that particular option. Then you get an step 1 option here, measure the diameter of the test sample using vernier caliper and calculate the moment of inertia. So you have an arrow mark indicating here how to calculate the dia using vernier caliper. So when you click on this particular instrument, it is calculating the diameter of the particular option. So here you have the initial diameter in two perpendicular directions. So one perpendicular direction has been provided with 22.70. Once again, if you click on the particular instrument, you have to get the next dia. Okay, so you are taking the average of this two particular dia format and then you are calculating the moment of inertia. So moment of inertia about neutral axis for the specimen I is equal to pi d to the power 4 divided by 64. So you get the value here, that is 13027.26 mm to the power 4. So once after you click this, you have to go for the next option. So the next step here is to measure the length of the specimen. So you have to click on the particular instrument here. So same instrument is used, that is vernier caliper, to measure the length of the specimen. So the length of the specimen is described as 41.3 mm. And the next option you have here is step 3, sample is placed in the UTM. So the main instrument you use to conduct the experiment is UTM. Okay, so here you are placing the specimen in the UTM machines and then you are applying the load here format. Okay, once you apply the load here, you get the dial reading gauge here. So you have to click on the particular option. Sorry for the interruption here. Okay, so I'll be continuing here. So once after the dial gauge has been provided here, you can click on the next button here. So here you have an option called green button. So click on the green button here. It will be providing the load in kg format with dial gauge reading in division format. Okay, so it will be reading out all the formations where you can see the specimen in a bend format. Okay, and it is calculated to 16,000. Okay, so once this is done, you can stop the UTM machine here. Okay, then you have to go for the next option here. So it will be providing the graph based on load versus dial reading. Okay, so here x-axis indicates the dial reading and y-axis indicates the load in kg format. Okay, so here you have the to view data, what are the data you have got from the particular UTM in the language format you have been recorded here, and you can view the slope option here also, where you can provide information regarding load in kgs and dial reading in division format with slope 1, slope 2 and slope 3. You have 3 graphs here involved here, so you can view the graph deformation, how it is taking place based on the reading here. So the next option you have here is the next step is observation and calculation. So here you have certain formulas to be applied here. So proof stress, here you have the formulas to be applied here. Whatever values you have got it, you have to put according to the formula here. Okay, so the next one is compressive string, that is in Newton per mm square. Then Sen modulus, that too have a formula here. So you can click on this to get obtain the formulas here. Just provide the value here, whatever you have obtained. So you can get the observations here. So here in the observation, you get all the details. So initial diameter in mm, length of the specimen, original cross-section area, slope 1, slope 2, slope 3, least count of the vernier caliper. Okay. So calculation part, you can just provide the data based on the formulas required, and then you can click on check options to check the entire detailings. So next one you have is assignments. Certain questions provided here for your better knowledge, and also the next option you have here is you can answer this quiz. So it's also, so if you give the wrong answer, you will get the you'll be highlighted with red color. Check your quiz mark here, just meeting the quiz option here. From this still, so you can just go through this particular videos for more clarity or anything. You can just go through this particular option, and you have the next some references based on the books referred, all the detailings and everything. Then you can provide the feedback based on the experience you have come across using the virtual lab. That's all about the test which have conceiving concepts based on strength of materials. So next I'm handing over to the next presenter, Q.
Come on. I'll share my screen. Tapasya, can you my screen get
Yes, Latesh.
yeah. Very good afternoon to everyone. Myself Latesh. I am currently working as a junior research fellow at System Design NITK, and today I'll be giving a small demo on few of the mechanical engineering labs under V Labs. So this is a V Labs website. So if I scroll down under broad areas of virtual labs, I'll find mechanical engineering. So most of the subjects that are covered under mechanical engineering, you will find it under the mechanical engineering broad area. Few labs like strength of materials that was explained earlier by Tapasya, you'll find under civil engineering domain, which is both common. Similar to that, you'll find fluid mechanics, fluid machineries, and some few other labs. So today I will go through mainly the mechanical engineering domain. So under mechanical engineering, so this is the UI. We'll find a lab ready to use and upcoming labs. I will go through one from each section. So first I will go through machine dynamics and mechanical vibration developed by NITK Surathkal. So click on it. So yeah, this is the UI that I will get. So this UI is very similar to whatever that has been already explained by the earlier presenters. So I will get introduction, objectives, list of experiments, target audience, course element, and feedback. So under objectives, the objectives that the user has to be the user has to get the under list of experiment. Will find around 8 experiments for this particular lab, the target audience, the course alignment, and also the feedback form for this particular lab. Under list of experiment, I'll go through free vibration of a cantilever beam. Yeah, again we'll get the same user interface. We'll get aim. For this particular lab, the aim is to find logarithmic decrement, damping ratio, and natural frequency of a cantilever beam under free vibration. So if I click on theory, I'll get the detailed explanation of a cantilever beam and how it acts under free and forced vibration condition, and the properties of the cantilever beam. Under procedure, I will get a detailed explanation on how to interact with the simulator. I'll also get a few formulas required for calculations, few tables required for calculation, as well as detailed explanation on how to interact with the simulator. And the self-evaluation section, there are a few multiple choice questions where the user can go through and test his knowledge before going through the simulator. So if I'll go to the simulator quickly, so if I click on the simulator, I'll get these 4 buttons, EXPR and EXPT, 3 experiments. So EXPR stands for explore phase. So in the explore phase, the user can explore the experiment. So he is given the freedom to change the variables and a few controls. So this is the simulation screen. So here we'll find the animation section. This is the variables sections, and this is the observation and calculation section, and this is the control section. So in the animation section, I'll find the cross section of the beam. Now since I have selected I section, it is showing me I section. So if I hover over this the cross section, I will find the properties of this section, and I'll get on the right hand side of that, I'll find the equivalent spring mass damper system. So with its properties, and I'll get a cantilever beam. So as I change the variables, the observation section will be updated, as well as the what are the properties of these 2 sections will be updated as well. So for example, now the selected material is steel. The mass is 29 kg. So if I change it to, let's say, aluminium, so now the mass has decreased from 29 to 26 kg. Similarly, I can see it with bronze as well. Same thing can be observed when I hover over these images. So now it is 29 for bronze. If I change it to aluminium, it has changed to 26. And when I change the cross section, the image will be updated as well as the properties. Yeah. Now I'll try to change the properties like length. So as I change the length of the cantilever beam increases. Now as I change the mass, the end mass over here, the radius will increase. And to see the damping ratio, I need to play the experiment. So there are 2 buttons given over here to play the animation and to check the graph. So if I play it, now since the damping ratio is very low, we'll see multiple cycles. If I slightly increase the damping ratio, we'll see that the cantilever beam will come to rest after a few cycles. And this same thing can be seen in the graphs as well. So if I go to graphs, now if I change the damping ratio, so as soon as I decrease, the number of cycle increases, and as I increase it, the number of cycle decreases. So in the explore phase, the student can go through all the variables, check out how each variable affects the cantilever beam, and test out different variable conditions, play with the simulator and all. Others, there are 3 experiment phase. So as you can see here, experiment phase. Once I start, simulator will be asking me to find the logarithmic decrement using the displacement versus time graph. So earlier I had shown the formulas for this. So the formulas is given in the procedure section. So you need to calculate the logarithmic decrement, and logarithmic decrement we need peak values of the graphs, and to find the peak values of the graph a slider is given over here. So by changing the by moving the slider I can find the peak values, and using those peak values I can calculate the logarithmic decrement. For now I'll enter some random value. Yeah. And if I had entered the correct green tick mark, which is shown, and to retry the experiment, I have to click on this restart button. And every time I restart the experiment, the variable section will change, and as well as the graph given over here will be changing. So as you can see, similar to this, there are two more experiments. One to find the damping ratio, and the other to find natural frequency. So yeah, and I'll go back. So after the simulator, there are assignment and quizzes. So in the assignments, there are few assignments for the user that he can try to attempt. There are quizzes and video references of a small Lagupata video explaining how the simulator should be used. There are references, the books that were used to development, feedback where you can share your experience while using the simulator. So other than this, there are 7 more experiments which are very similar to this. You can go through each and every one of them. Now I'll go to one more labs under V labs, mechanical engineering area. Under upcoming labs, I'll go to electron microscopy for beginners by IIT Kanpur. So if I click on that, again the user interface is very similar. I'll directly skip to list of experiments. Yeah, here we have 10 experiments. I'll go through basics of scanning electron microscopy. And yeah, so again here as you can see, there are cluster tabs. Instead of the assignments, quiz and we have pre-test and post-test. Other than that, we have aim, theory, procedure, simulation, references, and feedback. So in theory itself, here we'll find the video reference for this particular experiment instead of a separate tab. And also in the theory, a detailed explanation of the scanning electron microscope is given. In the procedure, instead of having the detailed images explaining the how the simulator works, we have detailed explanation on using the simulator. I'll go through the simulator once. So this is the simulator here. So here we have the animation section over here. We have the variables here and the result section over here. So now the instruction for me is to switch on the machine by clicking on the power button. So I'll do that.
Place the material into the machine by dragging and dropping it.
So now it is asking me to place the material by dragging it over here. So it is saying place the material here. So I'll select the metal.
Set the vacuum level.
Now I need to set the vacuum level. I'll set it to LV, that is low vacuum first. So it is saying that for metals it should be HV state. So high vacuum, I'll set it at. And yes, and also you can interact with the simulator to find the name of each part. Click on each part to get the source description of each part. Other than that, now it is asking me to set the voltage and turn on the beam. So I'll set it to around 10 kilovolt and turn on the beam. When I turn on the beam, a small animation will be played, and the image under the scanning electron microscope for metal will be shown. and I can change the magnification factor to zoom in, and change the brightness and contrast to check out the surface property of the metal or any other material that has been kept here. And if I and save this image for further use. And if I want to reset the experiment and test out with other materials given over here, to reset the experiment,
Welcome. Switch on the machine by clicking on the
and
power button.
I can redo the experiment again. So this was basics of scan electron microscopy. So I'll go through one more lab under upcoming labs. I'll go through dynamics of machines by NITK Surathkal. So again, the UI is very similar. I will directly skip to list of experiment, and I will go through Proel governor. So again, here the same interface. I'll get aim, theory, pretest, protest, post-test, procedure, simulation, reference, and feedback. I'll directly skip to the simulation. So this is the simulation interface, which is very similar to the one that I had explained earlier. So we have the simulation screen over here, the variable section, the control section. So here we can see the top and front view of a Proel governor as well as a free body diagram of the Proel governor. So as I increase the RPM, that is n value, we will see that the height of the governor decreases. The same thing can be seen with the mass as well. So as I increase the mass, the height of the governor decreases. So instead of having 3 different tabs for this particular experiment, for explore and experiment phase, this the simulator itself has the explore as well as experiment phase. So now I was exploring the experiment. To go to the experiment, a tab is given over here, and to check out the graph, small checkbox is given over here. So if I uncheck it, I'll get the free body diagram. And if I check it, I'll get the graph, and I can interact with the graph to find let's say if I wanted to find the height at 120 rpm, so I can use this graph and find the height. So I'll go to the experiment once. So there are 2 experiments. One is the calculation part, and the other one is to identify the parts of the governor. We'll go through the second one first. So in this experiment, the user has to identify the parts of the governor correctly. So let's say this is a pivot. So if I enter the correct value, a green tick mark will be shown, and if I entered a wrong value, the red cross mark will be shown. So this experiment is very simple. I'll exit the experiment. I'll go to the calculation once. So in the calculation section, the simulator will be asking me to find a certain value using the variables and the constant values. So for now, it is asking me to find the RPM for mass of 5 kg when the Proel governor height is around 132. So for now, I'll enter some random value. And once I've entered the value, if I've entered the wrong value, it will show me the correct answer. If I enter the correct value, it would show me the green tick mark. And every time I reset the experiment, the question might change or the variables might change. So the question will not remain same. It will change every time. So this was dynamics of machines lab. Other than this, there are few labs under VLab dev sites. So under approved labs, if I discipline, so there are 2 mechanical engineering labs, that is machine tools and analysis and synthesis of mechanisms. So you can go through these labs as well. This was a few of the mechanical engineering labs. I'll stop sharing my screen and end the session for now.
Thank you. you, Latish. We'll open the floor for queries if there are any from the participants. We'll open the floor for queries if there are any from the participants. You can unmute your mic or you can put a query on the chat box. Yeah, I request every participant to switch on their camera to take a photo. I request every participant to switch on their camera to take a photo. Queries. Thank you for giving an opportunity on behalf of Virtual Lab team and NITK Surathkal. We request every participant to look up of these resources and introduce it to others. For any queries, you can reach out us at solve@nitk.in and I request every participant to fill the feedback form. Thank you SNGCE College Management, Principal, all the HODs and all the faculty members and Esmila ma'am, Knowledge Center Coordinator. Thank you from our behalf. Thank you all.
Okay, thank you, resource persons. I would like to call upon Assistant Professor Pradeep.
A warm and grateful evening to our resource person, management, principal, faculty members, and everyone present here. It is my privilege to propose a vote of thanks and acknowledge the contribution of NIT Surathkal to our college and those who have worked really hard to make this event possible. I, on behalf of SNGCE and the entire fraternity of the institution, extend my sincere thanks to the Almighty for making today's webinar on Introduction to Virtual Labs a grand success. On behalf of SNGCE, I extend a hearty vote of thanks to our resource person, Vismaya, Senior Research Fellow, Akshaya, Anusha, Letish and Tapsaya, Junior Research Fellow at NITK Surathkal, who spares their valuable time from their busy schedule to grace the occasion. Today, we had an opportunity to hear the advantages and resources available in NITK Surathkal for conducting virtual labs, and this surely encourages us all in all our future endeavors. Your thoughts and facilities have enlightened our minds and have shown us a new path. Your deep and intellectual way of imparting knowledge has added to the glory of this event. Also, we have got a lot of information which will truly help in the journey of SNGCE. I also want to extend a heartfelt thanks to our principal, Dr. Kemthos P. Paul, who is the guiding force of our institution for taking all the efforts to sign the MOU with NITK Surathkal to conduct virtual labs. Our principal is being the catalyst that stimulated us to do our best. With deep sense of appreciation, we thank for his untiring efforts. An event like this cannot happen overnight. The wheels started rolling weeks ago. It requires planning, a bird's eye for detail. We have been fortunate enough to have backed by a team of very proactive and dedicated head of the departments of various branches. I also take this opportunity to thank all the heads of the departments for making this event a grand success. I would also like to thank all the faculty members who have blessed with their presence. Have a great day ahead. Thank you.